Good morning, everyone. Today we shall discuss about corona. What is corona? How corona will occur? When a normal alternating voltage is applied across two conductors with enough spacing in between, then there is no change in the atmospheric conditions surrounding the conductor. But if the voltage applied exceeds a particular limiting value, then the air surrounding the conductors get ionized, due to which hissing noise or faint violet glow appears, and production of ozone gas around the surrounding the overhead lines due to ionization of air is called corona effect. How the corona effect will occur: if the normal alternating voltage is applied between two conductors, then there will be no change in the atmospheric conditions. But if the voltage applied exceeds a particular limit, then the ionization of air surrounding the ionization of surrounding air around the conductor, hissing noise, and production of ozone gas in an overhead transmission line is known as corona effect. What factors affect the corona? Factors affecting corona is first atmospheric conditions. Okay, mainly corona will depend upon atmospheric conditions. The most important atmospheric factors are: if the for higher temperature and stormy conditions, dusty and rainy conditions, at that time the corona will be more. Okay, the corona will be more at rainy conditions, stormy conditions, dusty conditions. The number of free electrons will be more. At that time, disruptive voltage is low, so corona will increase. As atmospheric conditions means, if we take for mountain areas, then the corona loss will be high in the mountain areas. Okay, next, conductor size. How the conductor size is depend on corona. The conductors, if it is rough irregular surface, will give rise to more corona, because unevenness of the surface decrease the value of breakdown voltage. This affects the corona. This will raise the corona. Thus, a stranded conductor has a irregular surface and hence gives rise to more corona. That's why we need to take a solid conductor. Okay. Next is spacing between conductor. How the spacing between conductor will affect the corona. Spacing between the conductors should be very large, so that corona should be absent. They should maintain the limit. The spacing between the conductors have a limit. It should not cross the limit. The conductor spacing, spacing between the conductors should be maintained, so that corona is tolerable. Next, supply voltage. The supply voltage, if the lower voltage, corona may be absent. For higher voltage, the corona will start and it will get more. Okay, for higher voltage, disruptive, if the voltage is higher than disruptive voltage, corona starts. Higher the line voltage. Next, shape of the conductor. Shape of the conductor should be flat, oval, cylindrical, etc. Okay, it should be oval or cylindrical or flat. Okay, clearance from ground. The height of the conductor from the ground also affects the corona. The smaller the clearance of the conductor from the ground, higher is the corona. The clearance between the conductor and the ground should be more. Okay, next, advantages of corona. Diameter of the conductor is increased. The increased diameter reduces the electrostatic stress between the conductors. The corona effect reduces the effect of transient. Due to corona, the air surrounding the conductor is ionized and becomes conducting. This increases the virtual diameter of the corona. Corona reduces the effect produced by the surges and conductor is saved from possibility of lightning. It acts as a safety device. Some industries use this effect to remove unwanted volatile organics from atmosphere. Next, disadvantages of corona. The corona power loss reduces the efficiency of the transmission line. This is the main disadvantage of the corona. Corona effect produces ozone which lead corrosion of the conductor. Next, voltage drops occur in the line. The radio and TV interference occurs on the line. The corona effect can also damage the line insulation. If the cable insulation only reduces, then it cannot withstand. Okay, it cannot withstand, whole line can be damaged. Next, we shall go for the methods of reducing corona effect. How the corona effect can be reduced? By increasing conductor spacing. The conductor between conductor spacing should be a more. Okay, it should not cross the behind the limit, it should maintain. Okay, the practically spacing cannot be increased behind certain limits, as the cost of the supporting structure increases with the increased spacing. If we increase the spacing between the conductors, then the cost of the supporting structures will be increased. So we should maintain the limit. Okay, so that corona effect can be reduced by increasing conductor size. How we can reduce the conductor corona? By increasing the size of the conductor. Disruptive voltage is raised. If the disruptive voltage is raised, then the corona effect will be reduced. We can use the large cross-sectional area like ACSR conductor are used to reduce corona effect. Next, using bundled conductors. We can use the bundled conductor to reduce the corona. You can see by increasing conductor spacing. This is the ACSR conductor having a larger cross-sectional area are used to reduce the corona effect in transmission line. Using a bundled conductors, the spacing between the conductors will be maintained equally, and the bundled conductors produces less resistance and thus losses are reduced. Next, analysis of corona. Analysis of corona effects. Critical disruptive voltage. It is the minimum phase to neutral voltage at which corona occurs. At this voltage, at this critical disruptive voltage, the complete disruption of dielectric occurs. At this voltage, the potential gradient developed is equal to breakdown strength of the air, which is denoted as G naught. For different temperatures, G naught dash is equal to delta G naught. That is, delta is mainly dependent upon barometric pressure and temperature. You can see delta is equal to air density factor is equal to 3.992b divided by 273 plus T. That means it depends on pressure and temperature. M is irregularity factor is equal to 1 for polished conductors is equal to 0.98 to 0.92 for dirty conductors, 0.87 to 0.8 for stranded conductors. Next, visual critical voltage. At this voltage, we can see the corona glow appears. At this voltage, we can visible. It will be visible. Corona glow appears all along the line conductors. The equation, you can see it will appear in case of parallel conductors. The corona glow does not begin at the disruptive voltage. It will not begin at the critical disruptive voltage, but for higher voltage, that is visual critical voltage, it will appear. Okay, next, the equation is VV is equal to MV G naught delta R into 1 plus 0.3 divided by square root of delta R whole bracket log E D divided by R kilovolt per phase. You can see, you can observe what is meant by D. That is a spacing between the conductors. Distance between the conductors is D. That is the spacing between the conductors is D, and the radius of the conductor is R. Okay. Next, corona loss. Corona loss is power loss due to corona. What is the equation? Formation of corona is always, it may be energy loss which is dissipated in the form of light, heat, sound and chemical action. Power loss due to corona equation is P is equal to 242.2 into open bracket F plus 25 divided by delta close bracket square root of R divided by D open bracket V face minus Vc whole square into 10 to the power of minus 5 kilowatt